Welcome back to another Voltlog review. Today I have the pleasure of reviewing this brand new Rigol DHO800 series oscilloscope. More specifically, we have the DHO814 here, and we'll get into the details of the different models in this range in a minute. But first, I would like to thank Eleshop.eu and Rigol Europe for sending this unit for free for the purpose of this review. I was going to order one anyway, but they jumped in and helped me get this before it was available in stock at the distributors, which gave me a chance to play with the unit for a couple of weeks to gather some feedback to present in this review. And should you decide to order one after watching this video, please check out the link I'll place in the description to Eleshop.eu. They have excellent customer service, so it's well worth getting it from their shop. So if you've been following the channel, you know that I have been a happy user of the Rigol DS1054Z released in late 2014. I think I got it right after the official release and of course applied the well-known hacks to extend its bandwidth from 50 MHz to 100 MHz and unlock the various decoding features. I've also modded the cooling fan on that unit to make it a little quieter. This was shown in another video of mine and was all fine over the years. In fact, I believe that most of you, my viewers, have owned a DS1054Z at some point, and if that's the case, just drop a comment below because this was such a popular choice for hobbyists. However, these days oscilloscopes have gotten faster, smaller, lower noise, more bits, higher resolution, so it was time for me to upgrade. And I was waiting for the successor of the DS1054Z, and here it is. 8 years later, we get the DHO800 series from Rigol, which comes with a lot of improvements. That is to be expected after 8 years, but most importantly, it still keeps a very good entry point cost for one of these because the base model, the DHO812, starts at about 350 euros in the EU shops. And what are the most important improvements with this new series? Well, here's a summary of the most important upgrades. Number one, the minimum bandwidth, it now starts at 70 MHz. It still goes up only to 100 MHz, but that's just marketing strategy to keep it away from the other product ranges that Rigol makes. The sampling rate has a slight bump to 1.25 gigasamples per second. The vertical resolution was increased to 12 bits, and this is going to be such a huge selling point. It will make a massive difference in the way tiny signals are captured and visualized. Memory depth, again, slight bump up to 25 meg points, and I believe there is a software option to enable 50 meg points. Screen is still 7-inch, but it is now a higher resolution at 124 by 600 pixels and is a capacitive multi-touch. And the waveform capture rate can now go up to a massive 1 million waveforms per second in the special ultra acquire mode. The sponsor of this video is PCBWay.com, a professional PCB manufacturer with excellent quality and fast turnaround times. From 2 layers to advanced multi-layer flex rigid PCBs, PCBWay will have you covered. And you could also try the new module store on their website, where by using bonus points or cash you can purchase a great variety of electronic modules and related tools. Check out their website, link below. This new DHO800 series contains 4 models, and the main difference between them is whether they are 2 or 4 channels, 70 or 100 MHz bandwidth. We don't get a logic analyzer or signal generator option in this DHO800 series. For that, you would have to go to the DHO900 series, which would also unlock higher performance. What I have here today is the DHO814. And this is basically the top of the range from the DHO800 series, featuring 4 channels and 100 MHz bandwidth. Getting this unit out of the box is a shocker because of how unbelievably small and light the unit feels. And don't get me wrong, it still feels like a piece of high quality equipment, but just look at how small and thin they made this oscilloscope. I don't have the DS1054Z anymore, so I can't put them side by side, but this will take up so much less space on your workbench. It does feature a couple of very nicely designed tilting feet, which give it a very stable position on your workbench or desk, and even with this thin form factor, it does not fall on its back when pushing the buttons. The screen is now glossy, which might be an issue for some people due to reflections. The control interface, the buttons, the knobs will feel a little bit crowded for those that have very big hands, thick fingers. It's not an issue for me, but I am mentioning this as I know for sure some users will have trouble with the buttons being so close. I see a couple of new functions here for navigating the capture horizontally. I see a touch lock button, which is great to prevent accidental touch of the display. The power button is here. We have the USB on the front, great for plugging in external storage. This is practically in the same position as in the old version. On the back we have the auxiliary out BNC port. On this other side we have the Ethernet LAN, USB, HDMI, USB-C for power, which is something new, and I think we're going to see more of this on test equipment, and it's not bad at all. I do like this. And one thing that many will appreciate is the new VISA mounting holes on the back, which will allow you to attach this in ways that were not previously possible. For example, by using a monitor mount, an articulated arm, and have it swing out of your way when you don't need it and swing it back in when you need it for some measurements. And I'm going to try exactly that with a very simple monitor arm that I have, but I'll have to show you that in a separate video because this one will be pretty long just with the review part. In the box you get this 65 watts USB Type-C power adapter, which is PD capable, so probably means you can replace it with any other USB-C power delivery adapter that's capable of 20 volts 3.25 amps, maybe even less. And this also includes power banks, making this a good option for the occasional remote job. I would be surprised if this thing uses 65 watts. In fact, I'll probably take some measurements which I will insert here during editing. And it seems to be requesting 15 volts from the adapter, and the standby power usage is 0.2 watts, while the active power usage is around 35 watts, so well within the reach of an average power adapter or power bank, which is PD capable. Also, another scenario is where you have multiple of these instruments, 3 or 4, that use USB Type-C input. You can get a bigger 120 or 240 watt rated USB-C power adapter with multiple output ports, and you can power all 4 instruments from a single power adapter using just one socket at your workbench. So I find that pretty convenient. We also get a power cord, which will of course have the socket depending on the continent you live on. We get the 4 oscilloscope probes, a separate grounding cable, because I'm guessing that now with the USB-C adapter there is no direct earth connection to the scope anymore, and we can measure that with a multimeter between the earth pin on the power adapter and the earth on the oscilloscope, and yeah, it's 1 mega. This obviously has some advantages because it makes this act like a battery-powered scope isolated from mains earth, so there is no risk of potentially shorting some high voltage you are measuring to mains earth, but it also makes it more susceptible to common mode noise coupling, so it depends on what you're doing. Sometimes you might want to ground your scope, and with a floating oscilloscope there is also the potential for electrical shock to the operator in case of some electrical fault or improper usage, like some high voltage potential if you connect the ground clip of the probe and then the operator touches another ground clip on another channel or one of these shields, which are all of them connected together, then there is the risk of electrical shock to the operator. But I won't go into the safety aspects of using an oscilloscope because that's an entirely different topic. Now let's power the unit on and see how it goes. This is a cold start, and I'll probably speed this up. It takes roughly 48 to 50 seconds until it is operational. I would say this is a very long boot time, but that's pretty common these days with some form of operating system running behind all test instruments. Cooling fan noise is slightly annoying, seems to be running at a rather constant speed, and I think that's because it's a smaller fan and it has a higher pitch noise, and from what I've seen it's not a very standard setup for the cooling fan, making it very difficult to hack or replace, so that's something to keep in mind with this model. The graphical user interface looks very different to what we had on the DS1054Z, but then again, that was 8 years old. Now we get a bit more stylish graphical design here with shadows, gradients, transparency effects on the different icons. And in terms of brightness, I would say that it definitely feels a little bit weaker when compared to the DS1054Z, and whether that's due to lower brightness level of the display itself, or it's just due to the glossy screen, it just feels like there was more to it on the DS1054Z, which had a matte screen. There seems to be a new Rigol icon in the bottom left corner, which is like a start menu with different options. If I turn on all 4 channels, we notice the illumination, the LED color for the backlight of the buttons. They don't exactly match the colors of the waveform. We notice the channel 1, which is yellow, is kind of an orange color. I don't really like that. It's probably a very easy fix to open up this panel and just switch that LED for a more yellow one. Pressing the power button for a shutdown asks for confirmation, which seems a bit annoying. It's a physical button, it's shrouded, there shouldn't be much, accidental hitting of this button, so why does it ask for confirmation? I don't know, but luckily they thought of this, and just pressing the button again confirms the option and will shut it down. If we go into settings, we see that I'm running firmware version 1.01 and hardware version 12, and this Android version mentioned here gives it away that it's running Android under the hood. That's why it takes so long to boot the oscilloscope app. If we go into options, I see storage depth option limit, while the decoders say forever. So maybe I have a limited I think I just have the 25 meg storage depth, while there's an option to unlock 50. I don't know, I'll have to check that in more detail. Maybe I'll try one of the online available hacks. The channel input menu is a massive redesign. It has this new graphical drawing of the input path where you can select the attenuation, and it gives you this logic flow, and if you press the acquisition button, it will take you to the acquisition settings, and you can adjust the acquire mode or memory depth. And there are a bunch of new software features that are built into this new oscilloscope. I won't review these in great detail, but I will mention them. The fact that you can record the screen both as images and video. There is a new DMM mode. There is more internal storage where you can save things. There is improved serial decoding functionality. You can now split the screen into windows, so you could have the main acquire window in a split view with a secondary math window. You can even add a third window with something like serial decode output, and you can drag and drop these around, arrange them in different layouts, and that's pretty useful, especially if connected to an external display where you could see things on a bigger screen. It looks like you could even add 4 of these screens. But things do start to get a little bit crowded when you add so many of them. Let's not forget that all of this new functionality is very well designed and very intuitive to use, because I have not read any user manual, I have not touched this scope before, or another model which has this newer interface, and yet all of it felt very intuitive to use first go. Pretty much what you would expect from a well-established brand like Rigol. The touch lock function does exactly what the name implies. It locks the touchscreen to prevent accidental triggers, and I have to say that having this multi-touch capacitive touchscreen doesn't bother me at all, especially when combined with all of the important inputs also present on physical buttons and knobs. And I think it's particularly useful when navigating the settings menu, when setting, when you need a keyboard to put labels on stuff. It's very useful. It just makes your life easier than having to scroll or enter stuff by using a rotary knob like we did on the older models. The included probes are pretty standard. They have ×1 ×10 switch. It's a slightly different design from the old ones, but still the same overall. Good build quality. The only notable difference seems to be the cable length, which is now shorter on these I can't say that bothers me too much. I think the cable was too long on the previous edition. And the first thing that you should do when you get a new oscilloscope or a new set of probes is to compensate them, because they might not be measuring correctly unless properly compensated. It's fairly easy to do that. You just have to hook up the probe to the test signal on the oscilloscope, which is a square wave, and then you go on the small compensation knob with the included plastic tiny adjustment tool, and you rotate that potentiometer until you see the best looking square wave with good rise and falling times on screen. To be honest, on this particular model, it doesn't really make a huge change when rotating that knob, so it will probably be fine even without calibration. In the beginning of the video, I did mention that this scope has 12 bits of vertical resolution, but what does that mean, you might ask? Well, if you're just starting out with an oscilloscope, traditionally scopes have been using 8 bits ADCs for digitizing the input signal, and that means 256 different steps vertically. But when you want to capture a higher signal but also want to see the tiny details when zooming in, that can be a limiting factor, because when you zoom in you just don't get the details with 256 different steps. So newer oscilloscopes are now using 12-bit ADCs, and those extra 4 bits give it 4096 different steps, and that's 16 times more details captured on the vertical axis. And this will of course offer more accurate digital voltmeter measurements on the input channel. Plugging in a LAN cable will allow the oscilloscope to join your local network either via a fixed IP address or DHCP, depending on how you configure it, and then the oscilloscope can be accessed through its web control interface by using the assigned IP address, which can be viewed in the settings, or via the host name through the MDNS service. Now, the web control interface is pretty neat, because I often need to capture screenshots, and instead of going back and forward with external storage drives, plugging in the oscilloscopes, then plugging into my computer, I can just now connect via the web interface and capture and save stuff directly to my computer, both still images and video, which I can then use in my daily tasks and I can share with my collaborators. There is various additional stuff that you can do via the web, like issue skippy commands if you happen to be doing that, and it's all running very smooth and snappy over that 1 gigabit Ethernet link. Unfortunately, there is no Wi-Fi connection. It would have been nice to have it, because I do have that on my Mixig oscilloscope, and it's so much more convenient to have it automatically connect to Wi-Fi when I power it up, instead of having to connect an Ethernet cable. But hey, it is what it is, and there is plenty of other advantages that the Rigol has to compensate for this. And there is a discussion over on the EEV blog forum with users reporting that a very specific TP-Link USB Wi-Fi adapter will work with this Android system when plugged into the USB port of the scope, so that might be an option worth exploring. And finally, we should discuss hacking, because this is always a hot topic with Rigol oscilloscopes. Yes, there is a hack available for both the DHO800 and the DHO900 series that will enable the higher bandwidth and higher storage depth options. As always, the instructions for the hack are presented on the EEV blog forum. They depend on the firmware version you have, and you should know that you are voiding your warranty by doing this. For example, on my unit, I only have 25 megs of storage depth, and I could increase that to 50 meg by doing the hack. Also, as a physical hack, somebody created an entire back panel redesign for the scope, which doubles as a power bank to power the scope. I think that's pretty awesome, and I'll try to link that video in the description below. Somebody else designed an alternative logic analyzer and the signal generator PCB module to be installed inside the oscilloscope and upgrade the scope to that capability, which is crazy if you ask me. But the downside to that is that for the DHO800 series, there is some serious hacking to be done to the enclosure, whereas for the DHO900 series, which has that option available, then there is less mechanical hacking to be done. But what I wanted to outline with these examples is that there's definitely benefits to buying such a popular scope, because there are already plenty of hacks and upgrades available that you can try out. And if I would have to name 1 or 2 features that convinced me to get this new scope, It's the easy web interface that allows me to capture images and videos as well as to control the scope, and it's also the new 12-bit vertical resolution. But I would also be interested in hearing what are your thoughts. Let me know in the comments below if there are any new features on this scope that would convince you to switch to it. And if I have to name one thing that I don't like on this new DHO800 series, or maybe two things that I don't like, it's the cooling fan noise. I don't know why we can't have nice, quiet cooling fans on test gear, because in my humble opinion, it doesn't take that much more design effort. It doesn't cost more to design a more quiet cooling system. And we'll have to discuss more about the cooling system they use in the teardown video, which I still have to upload separately because the review was already too long. But if you can give me a good reason why they don't put quiet cooling systems inside test gear, let me know in the comments below. Is there something I'm missing out? And the second thing that I do not like about this scope is the new glossy screen. I think the previous model with the matte black screen was so much better. If you're excited about this review or have any questions, don't hesitate to leave your comments below. Let me know if you already got a DHO800 series and if you're happy with what it offers. As always, make sure to subscribe to the channel for more content ahead. Thank you for joining me, and I'll catch you in the next video.